Okay, so we're going to be talking about finding the LCD of rational expressions. Now, this is, expressions. This one can be fairly straightforward, but I will also say it's really easy to overcomplicate this particular topic. So with this, I want to remind you that the only thing that makes a common denominator, that LCD, so that LCD is your least, or sometimes you'll call it the lowest, common denominator, is that it's a multiple. It's always a multiple of your denominators. So the only thing, if I've got just regular fractions, so you've got 2/3 plus 1/6, here we're just looking for some common multiple of 3 and 6. And if I've just got numbers, it's pretty easy to just say, oh, I'll take a look at multiples of my large denominator. So 6, 12, 18, the fact that all of these are multiples of 3 tells us that 6 is my common denominator. So if I were to make these into equivalent fractions, I would just need to make them both sixths. And then I can multiply this by our well-chosen one in the form of 2/2, because that's what's missing. That would be a missing factor here. Now, what you might not realize is what we could do if we were to look at this in a factored form. 2/3 plus 1/6. If I were to factor these denominators, I could say, oh, I already see a factor of 3 in both of these. I can tell that this first one is only missing a factor of 2. So I would just multiply this by a factor of 2/2. I can always multiply by 1. When I do that, now I've got both factors, 2 times 3 and 2 times 3 in my denominator. That's all we're doing when we find our least common denominator. So let's say we have something a little bit more complicated. Let's say I've got something like 1/3x squared plus 1/6x. Now, I already know from our previous example that our common multiple of 3 and 6 is 6. So I could just say, oh, in this one, I would only need a factor of 2/2. That means I will have, so we're going to have that common multiple of our coefficients. So first thing that you're going to want to do is you need to find that least common multiple of those coefficients. Now, the next thing that we'd have to do is we'd also need to find, I've got this common factor of x, but we're going to need the highest power. Of our common factors, of our common variables. So in this case, I've got an x squared, which means I would need to have another factor of x over here, because x times x would be x squared. Now see what I want you to take a look at what happens when we multiply. This will give me 2 over 6x squared. Over here, I'll have x. 6x times x is going to be 6x squared. All we're doing is finding those highest power of those common variables, and we're finding a common multiple of those coefficients. That's how to find these kind of lowest common denominators, these LCDs. Let's do it again. Let's say I've got 2 over 5y, and I'll multiply this by 3 over 10y squared. Okay, here my multiple, the thing that would give me a common multiple of 5 and 10, actually 10 is already a common multiple of 5. So I would need a factor of, I'd need to have whatever is going to be in my denominator, it should be a 10. Okay, so I'd need to have a factor of 2. Both of these have y's, so I'm going to look to see what's my highest power. And my highest power here is 2. So I already have a y squared here. So that's going to be that common denominator. And in order to make this a common denominator, this would have to have another factor of y. Whatever I do to my denominator, I do the same thing to the numerator. So this would give me 4y, and then plus 3. So 4y over 10y squared plus 3 over 10y squared. And then at this point, I could just add these two expressions. So this would end up being 4y plus 3 over my 10y squared. And this would be done if I'm adding. We're not, strictly speaking, just doing that at the moment. Okay, last sort of iteration of this is something that looks really scary. Say we've got something that looks more like x plus 1, and then something else like x plus 2. These are different factors. With something like this, actually, you know what? I'll also make this an x plus 1 as well. With this, I already see that I've got a factor of x plus 1 in both of these. The only thing that would be lacking would be a factor of x plus 2 in this first expression. So I could multiply this by x plus 2 over x plus 2. So my common denominator would literally just be the product of all my factors. So this would be x plus 2 over, and guess what? X plus 2 times x plus 1. I'm not going to reduce that because our goal would be to add these together in just a moment. Because if I'm adding together expressions, I need to have that common denominator. So if I'm adding that together, I'll have x plus 2 plus 1, and end up with x plus 3 over this. X plus 2 times x plus 1. And we would be done with just adding. I had meant for this to be just to go over how to find our common denominators, but addition is probably one of the easiest examples that we have of doing that. That's all I've got for right now, so I will see you in the next video.